Alright, welcome to a video on the elimination method. So we've already learned how to do the substitution method, which is an algebraic method. So now we're going to learn about another method called the elimination method, which is also known as the addition method. So the overall goal for solving either substitution or elimination method is to reduce the number of variables that we have. If you look at these problems, such as right here, this first example, we have two equations with two variables. Our goal is to get it down to one equation with one variable so that we can solve it. And so the substitution method was a way of eliminating one of the variables, and so was the elimination method. We are literally going to eliminate one of the variables. So our steps. Step 1. You want to put both equations into standard form if they're not already done so. So remember, standard form is this thing right here, ax plus by is equal to c. We have the x term and the y term on one side and the number term, the constant term, on the other side. So we have this, for example, 4x plus 7y is equal to 10. That is an equation that is in standard form. And we want both of them like that. We want them to be lined up. Exactly how you can see this one is right here. 4x plus 7y is equal to 10. Negative 5x minus 7y is equal to negative 8. Okay, so second step. Check to see if the x terms or the y terms will cancel when you add the equations. And if they do, skip to step 4. So I'm going to skip the rest of those steps, and I want to show you what I'm talking about. If we look right here, we have 4x plus 7y equals 10. Let me zoom in just a little bit. There we go. And we have a negative 5x minus 7y is equal to negative 8. So I don't know if you knew this, but you can add two equations together. We can add downward, and that's why we want them lined up like this, so that we can add like terms together. And specifically, if you look right here, we have a positive 7y and a negative 7y. And we know when we add those, they cancel. That's the process of eliminating a variable. If I add what I have left, I have 4x and a negative 5x, that's negative 1x. You bring down the equal sign, and then 10 minus 8 is positive 2. This is an equation that doesn't have two variables, it has one variable. And that means that I can solve it. All I need to do is divide both sides by negative 1, and we get that x equals negative 2. Now remember, when we're solving a system, we're looking for the point where the two lines cross, at least graphically. And a point is two numbers. It is an x and a y. Okay, and that leads us to the rest of the steps here. But before we get too far ahead, let's make this a little bigger. Okay, so before we get too far ahead here, let's go back to our steps. So step 3 is, well, what if they do not cancel? So what I want to happen is what happened in example 1. So this little star here, our goal is to get something like, I'll use 7y and negative 7y. We want two terms that are going to cancel. Okay, so if they do not cancel, we need to make them cancel. For example, if we look at example 2, that doesn't happen, right? But I need that to happen. So what you're going to need to do is multiply one or both equations by whatever number by a number, whatever number you need, so that they will cancel. Okay, so we'll come back to this step in the second example, but let's go ahead and do what we just did in example 4. Okay, we added the equations. Okay, and one variable should cancel out, and it did. And we needed to solve the remaining equation, which we did. So like I was saying, we need to find the y. We only have the x. So what we're going to do, just like we did before in the substitution method, you are going to plug in the first variable, so whatever one you found, into, I didn't leave that much room here, either equation. As long as it has both the variables, and then you're going to get the other variable. So let's do that. Okay, so we know that x is -2. So what I'm going to do is, where I see an x, I could do it here, or I could do it here. I need to plug in that -2 into either one of those equations and solve for the other variable. So I'm going to choose this top equation because there's less negatives. So 4 times x plus 7y equals 10. So I'm plugging in -2 right here for x, which gives me -8 plus 7y is equal to 10. Add 8 to both sides. And then divide both sides by 7. And we don't get a nice number for y, and there's no guarantee that it has to be a nice number for y. 18/7 is fine. If it was a fraction, you can leave it like that as long as you reduce it. So my final answer is -2, 18/7. Now imagine you had to do this with graphing, solving by graphing. That would be gross. Okay, so this is an example of a case where the variable cancels out. One of the variables cancels out, and we didn't have to do anything. Okay, so right here where it says you try, I want you to give that one a try. -3x plus 4y is equal to -21, and 3x minus 9y is equal to 51. Okay, I want you to pause the video, give yourself an attempt, and then when you need help, if you get stuck or you need to know what the answer is, go ahead and push unpause. Okay, did you do the first step correctly? Did you add the equations and then the -3x and the 3x canceled? Okay, so we should get -5y is equal to 30. Let's move on to the next step. Alright, so we solve for y here, and you get that y is -6. Okay, right here, and I chose to do it in the bottom equation, but it doesn't matter. You could use the top one as well. And we solve this equation, and we get that x is equal to -1. Okay, so both of those cases, the variables canceled out on their own. We didn't have to do anything to them. Those are the easy cases. So now we need to focus on this step 3, the step where, what if they don't cancel? Well, you can multiply an equation by anything you want to, but we're going to multiply equations by some number that will help us create this goal of canceling. So let's look at example 2. So this is an example of a case where we have to multiply one equation. Okay, so take a look. You can choose the x's or the y's. One of them might be significantly easier. If you look at the y's here, we have a plus 5y and a negative 10y. Think of it sort of in the way you think of common denominators. Actually, it's going to be a lowest common multiple is essentially what we're using. And the lowest common multiple of 5y and or 5 and 10 would be 10. So it's pretty easy to make these the same number, but remember you also want them to have opposite signs. So this one's already negative and this one's already positive, so they already have good signs. We just got to make this into a 10y up here. So ask yourself, what do you need to multiply 5y by to make it into a 10y? And the answer to that would be 2. So I'm going to multiply this entire top equation by the number 2. And we get negative 12x plus 10y equals 34. Think of it like a big distribution problem. And don't forget to multiply the 17 over here. This number needs to be multiplied. Everything needs to be multiplied by the 2 in order for this trick to work. Okay, this is called an equivalent equation. It's not a different equation. It looks different, but it means the same thing. Now I don't need to change the bottom one at all, so I'm just going to copy it right over here. So I have 8x minus 10y is equal to negative 36. And now I have the thing I was looking for, opposite signed terms that will cancel. So now I'm going to go and add my equations up. They cancel out. Negative 4x is what I get when I add up those two x's, is equal to negative 2. Okay, so divide both sides by negative 4, and we get our answer. X is equal to 1/2. And as I said before, fractions are perfectly fine. Okay, so now, just like we did before, we need to plug in the x to get the y. So either equation will work. I'm going to use the bottom equation. 8 times x minus 10y is equal to 36. So my x, oops, sorry, I almost made a mistake. It's a negative 36. So my x was 1/2. So I'm going to put that right here. And 8 times 1/2 is 4. So I have 4 minus 10y is equal to 36. I'm going to take away the 4 from both sides. Get negative 10y is equal to 32. I'm going to divide both sides by 10. And I can reduce this fraction by 2, and that would give me 16 over negative 5, or negative 16/5. So my point is 1/2 comma negative 16/5. This is the ordered pair. Remember to put the x first and the y second. Okay, why don't you go ahead and give this one a try. Pause the video, give it a try. Okay, well, did you do the first step correct? There's more than one way to do this, but I think the easiest way to get one of the variables to cancel out is to multiply the bottom equation by 6, so that now I have a negative 12y and a positive 12y. An alternative answer would be to multiply the bottom equation by a negative 7. Actually, you know what? Let's not go there. That's going to be messy. We'll look at multiplying both equations by in the next example. Okay, so then go ahead and finish this problem. Did you get that x was equal to negative 3? Good job. Okay, now let's find y by plugging in x. I'm going to use the bottom equation. So that would be 2x. Oops, let's replace the x, right? So 2 times x, which is negative 3, plus 2y is equal to negative 10. So I'm using this equation right here. So that's negative 6 plus 2y equals negative 10. Add the 6 to both sides. 2y will equal negative 4. Divide by 2, and we get that y is equal to negative 2. So as an ordered pair, our answer is negative 3, comma, negative 2. Okay, so now let's look at a case where you have to multiply both equations. So these are cases, these are example of a case where both equations need to be multiplied. Multiplied. Okay. Think of a fraction problem you're doing common denominator, and you need to multiply both fractions by something in order to get the same denominator. That's just what this is. Okay. All right. So you could do the x's, or you could do the y's. And remember, you're doing a lowest common multiple. So just to remind you what a lowest common multiple is. Okay. If you look at the 5 and the 6. If I list multiples of 5, that would be 5, 10, 15, 20, 25, 30, 35. Those are multiples. So then multiples of 6 would be 6, 12, 18, 24, 30, 36, 42, etc. Okay, what you're looking for is the lowest multiple that they both have in common. And that would be 30. Which is essentially what 5 times 6 is. So if you're out of ideas, you can actually multiply the two numbers together, and that will always work. It's just, it may not be the lowest one. In this case, it is the lowest one. Okay, so let me give you an example with the 6 and the 4. If we do the 6 and the 4, so 6 and 4, let's do multiples of 6 and 4. So 6, 12, 18, I already erased 6, I should have just kept 6, 24, etc. 4, 4, 8, 12, there we go, 12. But actually if I kept going, you'd see 16, 20, 24. So 24 is a common multiple, it's just not the lowest common multiple. 12 is the lowest common multiple. So that's what I want to make both of these numbers into. So I'm going to do the y's, but you could do the x's. So I want to get a 12y and a negative 12y. Now this one's a negative, so I'm going to make that one the negative one. In order to make it a 12, I'm going to multiply it times 2. And so I get 10x minus 12y equals negative 14. On the bottom here, I need to multiply that by a 3, because I'm multiplying the 4 times the 3 to get the 12. So that's negative 18x plus 12y equals negative 42. Okay, let's add our equations together. The variables, the y variables are now going to cancel. That's what I was trying to achieve, and I did that. So negative 8x is equal to negative 56. And if I divide both sides by negative 8, we get x is equal to 7. And then the rest of the procedure is the same. We plug it in to get the other variable. So let's do 5 times 7 minus 6 times y equals negative 7. 35. Subtract 35 from both sides. Negative 6y is going to be equal to negative 42. Divide by negative 6. Y equals negative 7. So I get 7, negative 7. Okay, it's the last one. Your turn. Give it a try. I would suggest canceling out the x's on here, not the y's, just because the numbers would be smaller, but it's not impossible to do the y's. Okay, when you think you have your answer, push pause or push play. Okay, here's the first step. I multiplied the top equation by 3, the bottom equation by 5, and I get a 15x and a negative 15x here. Oh, I see a mistake that I made. Okay, so do you see it? Right here. I did not multiply the 5 times the 7 to get 35. Okay, everything looks, oh, and I forgot to multiply the 25 times the 3 as well to get 75. All right, let's check here. Did I do everything? Okay, good. So then I cancel out the x's. This would give me, looks like 11y, and this is going to give me 0. If we divide both sides by 11, you don't want to leave anything like that. That is not simplified. 0 divided by a number is always 0. So you should write it as such. Okay, let's plug in the 0 and get the x. So remember, we're plugging in for y. A lot of the other examples I've been plugging in for x because that's the one I found. You have to plug it in for the one you found. So I found y is 0, so that's what I need to plug in there. Okay, so I get 5x minus 8 times 0 is equal to 25. 0 just sort of cancels out. Divide both sides by 5. X equals 5. So my point, my ordered pair is 5, 0. The x goes first. Okay, hope this was helpful.